Oh, good morning everybody. Here I am back in this time we're in the outside workshop, and I've opened up this machine now, this therapy machine. It is actually a TENS machine. I never mentioned that before because when this was made I don't think TENS machines existed. I think that's a recent name. Anyway, here we are, we're inside it. And it's proving fascinating, really is. Let's see if we can point out some of the highlights. I'm struggling a little bit here. Things are falling all over the place in my little workshop because I'm not tooled up for stuff like this. So one thing that I found very, very interesting, resistors. Now look at this big fat chunky resistor here. Now it might not be obvious on the camera, but if you look at it very, very closely, after they've made this resistor, they've ground some of the carbon off in this area to change the value of it, because after manufacture it might not have been quite the value they wanted it to be. So somebody's ground it down a little bit to change the resistance, which is quite fascinating. We've got some very chunky resistors here, extremely chunky, and we've got this interesting gadget here which we'll come back to in a minute. But let's turn it around first. It's got two valves. One is a rectifier valve. Comically, if you notice, they've numbered them 1 and 2, valve 1, valve 2, which that raised a laugh with me. But one of them is a simple little rectifier, which is it, the top one. That is your rectifier. But what I found a little bit confusing is that with a rectifier you normally have AC going in one pin, DC coming out the other pin after rectification. Well, this has got two anodes, so you've got both halves of the AC cycle from the mains transformer going into it. Mains transformer is at the back here, weighs a ton. So you've got two anodes with AC going in them, and then we haven't got a cathode for the rectified AC to come out of. What we have is the heater, which you have to have with the valve, and the AC, having been rectified, comes out of the heater, the filament connections. So therefore the filament heater has got to have a separate winding on the transformer to the filament heater wires for this valve, which is something I've really never come across. But because you've got high voltage coming out on the heater winding on that one, you've got to have a separate heater winding for that. Quite strange. Then we've got a couple of smoothing capacitors, the old style 8 microfarad plus 8 microfarad. Those are very, very common in the early valve days, 8 plus 8, and a choke, smoothing choke, again very, very common. So you had your rectified current goes to the smoothing capacitor, the first 8 microfarad, then it goes through a smoothing choke to the second 8 microfarad. So that's quite standard old style electrics. There's actually a date on this capacitor, 1944. Here we can see it, December 44. So that gives you a clue to the instrument. Quite fascinating. Okay, go back here. Another thing which is very noticeable, everything has been done in the old style way, which I was shown by an ex-Rakel engineer, Clive, if you're watching this. When you do something such as a nut or a soldered joint, when you do it, you test it, check it, make sure it's right. Once you're happy that that solder joint or that nut is correctly tightened, you put a dab of paint on it to say, right, that one's been done. And so every soldered joint has been checked and then had a dab of paint on it. And likewise, every nut has been tightened to the right tightness, if that's the correct word, and then a spot of paint put on it. Fascinating old style electronics, or electrics. This is not really a mass-produced device, because if you look in these bits of metal, there's lots of holes. And again here, as though they've made the holes, found that they didn't turn out to be quite where they wanted them to be, and so they've made another hole. And it's not as though they correspond, because the holes in this bottom piece are different to the holes in the top piece. So it's been very much trial and error as to where to drill the holes and put the screws. Quite fascinating, that. Now, getting into the electric circuit a little bit. Oh, no, not yet, but another fascinating thing is that this piece of Paxolin, which has all been assembled on, has got lines drawn on it with some scribe. So they're actually measured and scribed lines on this Paxolin and then drilled the holes. So again, it's very much not mass production. All measured out individually, scribed and then drilled, whereas I would have thought if you was making a few of these, you'd make one, drill the holes in it, and then use that as a template in your pillar drill and drill through it for all the others. But no, each one has been measured out individually and drilled. So very much not mass production, very, very individually produced. Now, I can't go through the exact electrics diagram, because I really need to get some power on it to check things. But it's not going to work. If I put power on it, it's not going to work. So I doubt if the capacitors, after 1944 capacitors, would be working. I doubt if the valves would be working. And this is a bit stupid. When they designed this and built it, you can't unplug the valves, because if we look here, you've got this potentiometer there, right against the valves. So there's no way of unplugging these valves now if you wanted to replace them. You'd have to strip the unit down quite a lot. I was going to say you'd have to unscrew this front piece, but then there's wires there which are under tension, so you wouldn't get enough, so you'd have to take the wires off. It'd become a major job just replacing the valves, which doesn't make sense. For old style electrics, you used to always be able to unplug the valve, but not on this. Okay, so we're with it so far. We've rectified the voltage. We've got two separate heater windings. We've got a black one, a couple of black wires going for the heater of the rectifier valve, which of course also has a high voltage on the output. And we've got a twisted pair here going to this other valve, which is a triode. It's traditional to twist your heater wires to stop home pickup, especially since you're driving this triode. Right, so we've got both valves, AC going in there, rectified, coming out, being smooth, filtered, whatever, and ended on this triode valve. Now, we want to end up with AC, because being a TENS machine, or TENS style machine, it puts out a variable frequency, controlled by the knob on the front panel, which is labelled as frequency, very conveniently for us. And so we've got AC, which varies on frequency. Goodness knows exactly what frequencies it puts out on this. Probably something like, say, 20 to 80 hertz. I don't know, I'm guessing. But that's the sort of region you'd expect with a TENS machine. So, having finished up with DC, we now want to turn it into AC. And we do that with this little gadget here. And this again is very strange. It's not going to work at the moment, but it appears to be some kind of bimetal strip with wire wrapped round it to heat it up, some kind of resistance wire, and that will heat up the bimetal strip and cause it to bend and here in front of it we've got a contact, and so the bimetal strip should normally, I would expect, be in contact with that, touching that contact. The current will flow, it heats up, bends away from the contact, cools down because the contact is broken, goes back to touch the contact again, and so the cycle continues, and that gives us our AC with this thing flexing backwards and forwards. But it's not touching it anymore, so that's another reason it will probably no longer work. It would need some kind of treatment there. This bimetal strip seems to be connected to the heater circuit of one of the valves of the triode. So the power is coming from the low voltage heater to heat that up and cause it to go backwards and forwards to make and break to give us our frequency. It's also wired through the knob on the front, which is a wire wound resistor. I did measure the resistance of it, but it doesn't really matter. It's a wire wound resistor, and so the heater circuit goes through the wire wound resistor to this, so we can limit the current, the voltage flow or whatever through this device by turning that knob on the front, and that will change the rate that this heats up and therefore makes contact. So that's how we have our vibration. So that gives us AC. I'd love to know what voltage it is, I really would. Possibly these resistors have something to do with lowering the voltage, but sadly I'm never going to know. I'd love to know what voltage it is, because it goes through this thing and becomes AC. So now having AC, which, as I say, probably 20 to 80 hertz alternating current, we now have to put that through a coil to give us the electric shock that you get with these TENS machines. And if we turn it round here we have the long coil which turns the AC into the necessary voltage for the terminals of the TENS machine. And the mysterious knob which was on the outside of the case, which is another fascinating thing, this was the mysterious knob, and what it is, it doesn't turn. I thought it turned because it was jammed in, but it actually pulls in and out, and it slides in and out of that coil to change the coupling between the primary and secondary. Now that's not to increase or decrease the voltage as you would think at first, it's to change the shape of the pulses, because that's another gimmick with TENS machines. They like to give you a different shape pulses which alters the therapeutic value, if you believe these machines work, which well, I don't personally, but a lot of people do. So that slides in and out, changes the shape of the pulse, and you've got two knobs on the front to the terminals which give you the output voltage. So you can alter the output voltage with knobs on the front, and you alter the shape of the waveform by sliding this in and out. Well, that's all I've gathered so far about this machine, and I've now got to plan what I'm going to do with it. Now, you know, the obvious thing people would say is restore it, and it would be nice to see it working again, and I'd like to have other people's feedback on this. But what I'm thinking myself is, because of the nature of it and dealing with high mains voltages and things, it scares me. I don't fancy using it myself, connected to the mains, being rectified through these valves and capacitors and things, and trusting that the leakage from this transformer after all these years is still sufficient to give a safe isolation between primary and secondary and not electrocute me. So at the moment, what I'm planning to do, I've got to do more research into it, is remove all this ancient electrics. Oh, shame, isn't it? But remove all the ancient electrics and replace it with something more modern. So if I can find out what the the turns ratio is of this coil here, which is going to be the next thing to investigate. If it gives a suitable ratio, I may still be able to use that to generate the high voltage bolts. Depends how many turns are on it, we shall see. But all the electronics, the smoothing capacitors, transformers, valves, everything will be stripped out and replaced with a single little NE555 8-pin is it, integrated circuit, which a lot of us electronic guys are quite familiar with. So put in a single NE555, which will give me a variable pulse rate of whatever I want with these tens machines. Put that into a higher powered output transistor, and that will give me my pulses, and then hopefully I can keep that transformer. That is the plan so far. The other challenge is of course the case. The case is a very nice piece of woodwork. It looks like mahogany to me, and it will be a major restoration job trying to repolish and restore the wooden case, and that takes me into a whole different field of woodwork. But that's what we've discovered so far about this little gadget, and I shall now investigate how I'm going to restore it, and whether I'm going to go ahead with the NE555 route, or even replace it with a modern tens machine. There's no reason why I couldn't get a modern 9-volt operated tens machine and put that inside and just connect it to the appropriate knobs. I know it seems a shame, but you've got to think of safety, and you can't really trust your life on connecting yourself up personally to mains driven electrics of this age, or not in my opinion. And no, I'm not going to put it on the part tester to find out why. You couldn't, because there's no earth. It's class 2, it's not earth. Oh, would you risk your life on a 60 or 70-year-old class 2 insulated device? I think not. Okay, thanks for watching.